This video is on basic operations which can be applied on the arrays. Let us first concentrate on element-wise operations. Suppose we have two lists, cured cases in March and death cases in March. We create a matrix 1 with the help of np.array function. Now this matrix 1, similarly we create matrix 2 which displays the cured and death cases in the month of April. Let us now talk about element-wise addition of two matrices. We simply need to write matrix 1 plus matrix 2. Likewise, we write matrix 1 minus matrix 2 to get the subtraction of two matrices. Now, let us see about multiplication. When we talk about element-wise multiplication of the two matrices, we write it as matrix 1 into matrix 2. You can see the output here. The first element in the output is 1100. This is by multiplying the first element of the matrix, that is 20, with this next element, first element of the second matrix, that is 55. Now, this is element-wise multiplication. We need to do matrix multiplication. Let us first check the shape of these matrices. When we see the shape of these two matrices, we find that the shape of matrix 1 is 2, 4 and the shape of matrix 2 is also 2, 4. That means multiplication is not possible. In order to multiply, we have to change the shape of the matrix to 4, 2. That means we need to transpose the matrix. We simply do it by calling the transpose function. We do it like matrix 2 dot transpose. This will transpose the function, the matrix 2, and when you see the shape now the shape of this matrix T will be 4, 2. In order to do matrix multiplication, we use @ sign. So we write it as matrix 1 @T to get matrix multiplication. Now here the first element is 10711, which is multiplication of 20 by 55. Further, element-wise operation is exponentiation, which is denoted by double multiplication sign, double asterisk sign. When we write matrix 1 double asterisk into 3, this is exponential result of matrix raised to power 3. When we say here the first element is 8000, this is 20 raised to power 3. Further, we have here division. When we do matrix 2 divided by matrix 1, we get the division result. Here 2.75 is 55 divided by 20. When we write matrix 2 percentage matrix 1, this is modulo operator, which is element-wise remainder of division. That means once we divide 55 by 20, integer division, then the remainder remains 15. So these were the element-wise operations which would be applied on the matrices: addition, subtraction, multiplication, exponentiation, division. Along with that, we have also studied about modulo 2 and the transpose function. Now, moving further on other operations which can be applied on the arrays. First in this is sorting. Sorting is to arrange the elements of an array in hierarchical order, either ascending or descending. By default, NumPy does sorting in the ascending order. For this, what you will do is that you will call the sort function. You can see here in the code, you have an array summary. Now, in order to sort it, you write the function as np.sort and in bracket you give that array which needs to be sorted. So you write in bracket as summary. Output will be your array in ascending order. Just look at the output. The unsorted summary array is 550, 670, 980 and 440. But the summary in ascending order comes out to be 440, 550, 670 and then followed as 980. Now what if we want the summary to be displayed in descending order? In NumPy, np.sort function does not allow us to sort an array in the descending order. So what we can do is that we can reverse an array utilizing list slicing in Python. It has been sorted in the ascending order. That means once you have obtained the ascending order array, that is ASC underscore summary, what you do is that you do slicing by using the square brackets and you reverse the entire array, colon, colon, -1, which goes it in reverse array. So your output will be 980, 670, 550 and 440. Now, let us talk about sorting in two-dimensional arrays. It can be done along either of the axes, that is row-wise or column-wise. By default, sorting is done row-wise, that is axis equals to 1. It means to arrange the elements in each row in ascending order. Let us talk about this matrix 1 again. When you write np.sort matrix 1, it will sort matrix 1 in the ascending order with axis equals to 1. That means it will do sorting row-wise. That means it will arrange the elements in each row in ascending order. So each row here, first row is 270, 27, 780 and 52, which will be arranged as 27, 52, 220 and 780. Likewise, all the rows will be arranged in ascending order. But when you keep axis equals to 0, then the sorting is done column wise, which means each column is sorted in the ascending order. Here you can see in the output, the first column was having values 220 and 201. Now the output matrix will have first value in the first column as 201 and second value as 220. So it has been sorted on the basis of the column. Next, we are talking about concatenating the arrays. That is, joining two or more arrays. You can concatenate one-dimensional arrays by appending the sequences one after the another. For this, we use the NumPy dot concatenate function, which concatenates two or more two-dimensional arrays, either row-wise or column-wise. By default, the concatenation of array happens along axis 0. Let us understand this with an example. See here, you have two arrays. First array is array 1, which is being created by using array function having two lists. First list having the values as 10, 20 and the second list having the values as minus 30, 40. Now you create another array, array 2, by the function np.zeros, where you give the dimensions as 2, 3, which means it will have 2 rows and 3 columns in each row. By default, it will create the array with floating point elements as 0.0 as each element. But here we want it to have integer values. So in that case, we are writing explicitly as dtype equals to array1 dot dtype. This will make sure that the data type of each element of this array 2 will be the same as the data type of the array 1, which comes out to be integer. So once you display these two arrays, you will get to know that array 2 will have 3 columns and 2 rows with each element having the values as 0 instead of 0.0. Now once you check the shape, you check that array 1 is having the shape as 2, 2 and array 2 is having the shape as 2, 3. Now here, once you use np.concatenate array1, array 2 on axis equals to 0, 1, that means it is having row-wise joining. So row-wise joining means that the first row of array 1 is concatenated with first row of array 2. That means your first row of the array will be having values 10, 20, 0, 0 and 0. Likewise, the next row will have elements as minus 30, 40, 0, 0, 0. Just look at here that this array will be having the values in the form of the list. Now, let us move further. Next is reshaping, where you can modify the shape of the array by using the reshape function. Just remember one thing, reshaping an array cannot be used to change the total number of elements in an array. If you do that, then it would result in an error. You can see that this is the matrix here in the figure, which has got 2 rows and 3 columns. When you write np.reshape3, 2, it will have now 3 rows and 2 columns. But the number of elements in the array remains same. Let us understand this with this code. Now here we are trying to create an array 3 with a range function np.arrange 10, 22. That means you will have an array with starting value as 10, ending value as 21 and step size as 1. So this is the array 10, 11, 12, 13, so on till 21. Now you see the shape of this array, array3.shape. So you will see that it will come out to be 12. Now, if you reshape it 3, 4, then it will have 3 rows and each row will have 4 elements in each. So you will have 10, 11, 12 and 13 as the first row, then 14 till 17 as the second row, and 18 till 21 as the next row. Likewise, if you do array3 dot reshape, then you will get the value with the parameter values as 2, 6. Then you will get the values as first row with 10 to 15, next row with 16 to 21. Now, moving on to the next, that is splitting. We can split an array into 2 or more sub-arrays with the help of NumPy.split function. By default, NumPy.split splits along axis equals to 0. Now here there are two ways to split it. First, we can either specify sequence of index values where an array is to be split. Or the second way is that we can specify an integer n that indicates number of equal parts in which the array is to be split. Let us understand these 2 points with the help of an example. See, here we have created again an array by arrange function, giving the value as 10. So the array X will have values from 0 to 9. Now let us try to split this one-dimensional array into 5 equal parts. So what you will do is that you will write np.split x, 5, where first parameter is the array which needs to be split and the second parameter is the number of equal parts in which you want x to be split, that is 5. So the output will be first array with value 0, 1, second array with value 2, 3, so on till array having value 8, 9. So you are having here values from, you are having splitting of the array into equal parts. Moving back to the slide here, we can see that the second last line, the second method, it says we can specify an integer n that indicates the number of equal parts in which the array is to be split. So here n in our example was equals to 5. Now moving further in the example, what happens if we pass a list of indices along which the array is to be divided into the subarrays? That means if we do pass it as np.split x, a list which consists of 4, 6, 7 and 9. It means that total number of elements in the list are 4, so it will have 5 partitions. The first partition will be having values from index 0 to 3 because the first element in the one-dimensional index list is 4. So your first array will be having 0, 1, 2 and 3. The second partition will have value from index 4 to 5 because you have specified the second element in the list as 6. The third partition will have value from index 6 to 6 because you have specified the third element as 7. The fourth partition will be from index 7 to 8 because you have specified the next element as 9. And the last partition, that is the fifth partition, will be from index 9 to the end of the list. So it will have only last element as 9. So your first array will have values 0, 1, 2 and 3. Second array will have values 4, 5. Third array will have only single value as 6. Fourth array will have value from 7 to 8. And the fifth array will have value as 9. Moving back here, the third last line says we can either specify sequence of index values where an array is to be split. So the sequence of index values was given in the form of the list of values. By default, NumPy will split the array at along axis 0. Moving further, let us see one more example of splitting. Here, what we are trying to do is that we are trying to create an array with the arrange function with the value as 16. So that means the array X will have values from 0 to 15. Soon after we create the arrange function, we reshape it from the one-dimensional array to a 4 cross 4 matrix. So here you will have a matrix with 4 rows and 4 columns having the values ranging from 0 to 15. Now we will split the above two-dimensional array into sub-array using indexes list of 1, 3. When you do it like this, you will have two elements in the list 1, 2. That means you will have 3 partitions. First partition will be from index 0 along axis 0 because the first element in the list is 1. So that means index 0 till 0. That means you will have first row 0, 1, 2, 3 as the first partition. Now the second partition will be from index 1 to 2 because you have specified next element as 3. So your third partition will be from 1 to 2. Now the third partition will be from index 3 till the last element of your array. So these are the partitions which you will get. First will be an array having only the first row. Second array will have the second and the third row. The last array will have only the last row of your 4 cross 4 two-dimensional array. So this is how splitting works. Thank you for attending NumPy sessions. Now you can have your hands-on training for the rest of the session.